Hello, I'm Mr. Malden, and this is the Math Toolbox. Today we are combining like terms. If you're new to my channel, I teach 7th grade math, and I would encourage you, if you're in 7th grade or 6th grade or even 8th grade and you're trying to remember some of the principles that you learned last year, click the subscribe button down below. We're going to go through the whole year. I'm going to record every single lesson this year, so if you're at home quarantining for whatever reason, you're always welcome to come here and you can be able to learn what you need to learn. But again, today is we're covering combining like terms. So I just want to let's go ahead and get into that with a bit of a review. If you watched the last video over expressions, then this will be a little bit of a review for you, but if not, then maybe it's brand new. We've got an expression right here, 3x minus 2y plus 5. That is an algebraic expression. The reason why we call algebraic is because it has variables, it has letters, all right? Up until about 6th grade, all you've ever dealt with are numbers, and so all the things you've ever dealt with are numeric expressions and equations. But now we're going to start getting into algebra. So that's an algebraic expression because it has a combination of variables and constants and things like that, all right? So let's just talk about each of the pieces of this. You've got the letters themselves. Those are place savers for unknown numbers. They're called variables. They have the title of a variable. And by this point, you have seen variables. You shouldn't be unfamiliar with those completely, but that's what those are. The numbers that are attached to the variables have a special name as well. They're called a coefficient, all right? And the fact that they're attached to the variable, they're right next to it, signifies that they're being multiplied by the variable. So the number in front of the variable that's being multiplied by the variable is a coefficient. Now, that's as simple as we can make that right there, that 3x, because we don't know what x is yet. So once we find out what x is, we'll multiply it by 3. But right now, we don't know what x is, so you can't write it any more simple than that, right? You're going to have to put your coefficient right next to your variable, just like that. All right. The next number that we'll talk about is a constant, and it's the number that does not have a variable attached to it. All right. It's a constant because its value remains the same. All right. We're not multiplying it by anything else. That 5 right there, it's just 5. All right, and so we call it a constant. And finally, there's kind of an all-encompassing vocabulary word called terms, and that refers to everything that you see here. You see the 3x, you see this 2y, but this subtraction influences that 2y to be negative, so that's a negative 2y right there, and then you've got a positive 5. Those are all the terms from that expression right there. All right. Well, today we want to get into combining like terms, all right? Like terms are going to be those terms that have the same variables with the same exponents. But let's just remember what we need to do to this expression before we ever start trying to work with it. So we're going to try to answer this question right here. What are the terms in the algebraic expression? But if you watched the last video, then you'll know that there's something inside this expression that we need to work with, all right, before we ever do anything else. And so maybe you did watch the last video. If you did, then I want you to pause right now, and I want you to write it out on your own sheet of paper. What do you need to do to this expression before you do anything else? For those of you that didn't watch the last video and don't know exactly what I'm referring to, you need to apply keep, change, opposite, all right, to any subtractions that you see. So if you have a really long expression, all right, the first thing that you want to do is turn any of these subtractions to an addition problem, and you have to do that by applying keep, change, opposite, all right? And so if we have this expression right here, 3j minus 5h minus 7 plus 2h plus 4j plus 14, we're going to go to these subtractions right here, all right? And we're going to apply keep, change, opposite. All right, so you're just turning that subtraction to an addition problem. Now you can't just change it to addition and be done. You have to apply keep, change, opposite, which means if I change that to addition, I've got to turn the next number to its opposite. So the opposite of 5h was negative 5h. And here's one more subtraction right here. I'm going to apply keep, change, and then that next number has to be its opposite. The opposite of positive 7 is a negative 7. All right, so that's the first thing that you want to do to your expressions in order to be able to work with it is turn everything to an addition problem by applying keep, change, opposite. And then you can accurately write out what the terms are in the algebraic expression, all right? So now that you have everything turned to addition, you can accurately see that there's a 3j, and there's a negative 5h, and there's a negative 7, and so on and so forth, all right? You have all the terms there. You can go ahead and write all the terms out, all right? So again, that word terms is kind of an all-encompassing vocabulary word that just refers to all the variables with their connected coefficients, and then all the constants as well. So you write all those out, all right? When you're combining like terms, the first thing that you want to do is just, first of all, just identify what are the terms, all right? And then like terms, like I said a while ago, are going to be terms of an expression, all right? So this is an expression right up here. And the terms of the expressions that have the same variables with the same exponents. And in this lesson, we're not really going to be concerned too much about the same exponents because we don't see a lot of that. But this is what they're referring to, all right? When you have a variable x, and then you have the variable x to the power of 2, right? This looks like the same terms, maybe like terms, because they both have an x, but they're not like terms because they don't have the same exponent. So you want to make sure that when you're combining like terms, that you're recognizing that even if they have the same variable, they're not necessarily like terms, all right? They have to have the same variable with the same exponent. Now, if I had a 3x here and a 7x squared, all right, I know these don't have the same terms because they don't have the same variable with the same exponent. But if I added this exponent right here, well, now they do. Now they do have the same terms, all right? And you can go on to the next step, which is to actually combine them. So that's the first thing you want to do is just make sure that you're recognizing your terms, all right? And you're kind of taking a look at what all your terms are. In this expression right here, I see terms that have j, a variable j. I see terms that have a variable h. And then I see terms that are constants, all right? Here's another one that has an h. Here's another one that has a j. And there's another one that's a constant, all right? So the first thing you want to do is just kind of write out what your terms are. Then the second thing you want to do is kind of group or make kind of a mental note of which ones have the same terms. And if you'd like to, you can just kind of write those separately, you know, in groups like I did right here. I've got a 3j and a 4j. I've got a negative 5h and a 2h. And I've got a negative 7 and a 14. And the reason why I grouped these together is these both have j's, these both have h's, and these both have no variables, all right? And so I can group those together, all right? And then once I group those together, I'm going to want to write them in an addition problem close together. So this is moving on down. I'm actually getting to the point where I'm about ready to combine them. The first thing I needed to do is just recognize what terms I have. Second thing I need to do is regroup the expression with all the like terms placed next to each other, all right? Now we had already turned everything to addition, all right? So we're just gonna put a plus sign between each one of these terms. But I've got a 3j, all right? And I'm going to regroup the 4j right next to it. And the reason I can do that is the commutative property of addition says that when it's all addition, you can move the numbers around, all right? So I'm going to move these around to be able to put these terms that have the like terms next to each other, just like this. All I've done is taking that expression that I had before, all right, this expression right here, and I've rewritten it using the commutative property of addition. I moved these around to where the j's were next to each other, and the h's were next to each other, and the constants were next to each other, just like that, all right? And then I can go on and I can actually add these together. Now, if they have the same variable, right, in order to be able to combine them, all you have to do is add their coefficients, all right? This 3j is kind of like j plus j plus j, right? And this 4j is like j plus j plus j plus j, right? That's repetitive addition, which is the same thing as multiplication, all right? I have a plus sign in between these. When I add that 3j and that 4j's, it's like I'm adding all the j's together, all All right? So whenever you're adding or combining like terms, if they have the same variable, then all you have to do is take their coefficients and add them together. 3 plus 4 is 7, and make sure you attach the variable right next to it, just like that. So I have 7 J's altogether. And then I'm going to move on. I've got a negative 5h and a positive 2h. All right. I'm just going to, because these both have h's, I'm going to add the coefficients together. Now I'm going to be careful here because this is a negative 5 and a positive 2, which means these two numbers are at war with each other. They're at odds with each other. Now I could put those on a tug line if I needed to, just like this. And this is a tug line for h's. All right. I've got a negative 5 over here. I have a 2 right there. So is there a war? Yeah, 5 minus 2 is 3, and negative wins the war. So I've got, whenever I add negative 5 plus positive 2, I get a negative 3, and then I need to make sure that I keep my variable that it is a coefficient of, okay? So I have negative 5h's, and I have positive 2h's. Those combine to a negative 3h, just like that. And then finally, I've got my negative 7 and a positive 14. And I know a negative and a positive, they're at odds with each other. All right, so they're really going to subtract them and keep the sign of the larger number. The larger number was 14, so it's positive. So that's going to be positive, just like that. So, all right, so now I've combined the like terms. I've got 3j plus negative 3h plus 7. All right, now I'm going to do something that, for some, it's going to be a tad bit confusing, but just understand what we're trying to do here. This is a right answer, okay, just like this. That's a correct answer, right? But we want to take that correct answer and we want to, for our final answer, write it as cleanly as we can. If you'll remember, when we were up here, when we wanted to work with this expression, we applied keep, change, opposite to turn everything to addition like that, all right? But we're going to now go back and we're going to simplify this, all right, by applying what I call reverse keep, change, opposite, which means I'm looking for any of these plus negative situations right here or minus negative, and I want to write that a little bit more simply, all right, because we know anything that's, plus negative is the same thing as subtraction. So if I see a plus negative situation like this, I'm going to apply reverse keep, change, opposite, which is I'm going to keep the number in front of that plus sign. I'm going to turn that plus sign back to subtraction, and I'm going to take that negative 3h and turn it to its opposite, just like that, and then finish on through. So this is right. This is better, all right? So you want to write it just as simply as you possibly can, all right? So that's a lot of information for you to try to remember. I get it. Math, it doesn't have to be difficult, but there are a lot of rules that sometimes you just have to kind of wade through to be able to, get to the right answer. So the right answer for this one, the final answer, is 7j minus 3h plus 7. All right, now we're going to go back here, and I want you to try this one on your own. So take this one right here, pause the video, and I just want you to write out what are the terms to the algebraic expression, right? Hopefully you wrote out 4a and 5b and 11b and 3a and 9 and 21. Remember that word terms just refers to all of the individual terms, kind of an all-encompassing vocabulary word, all right? Then I want you to rewrite this expression, all right? You're going to take this expression, and we didn't do any keep, change, opposite because we didn't see any subtractions, all right? So just remember that. Keep that in the back of your mind maybe for the next one, all right? But in this one right here, we didn't have to rewrite it. So now we're going to rewrite this expression with addition, all right, all the way through. But we're going to put all the terms that have the same terms next to each other, all right, that have the same variables. So that 4a right there, we're going to want to go through and see if are there any other terms that also have an a. And if they do, we're going to want to write that right next to the 4a in an addition problem. So why don't you go ahead and pause this and just try it. Give it a try. Even if you think you're going to get it wrong, go ahead and give it a try and then unpause it and see what the answer is. All right, so hopefully you've paused it. Maybe you unpaused it now. But here's the answer to that, all right? You've got 4a, and we're going to add to it, we're going to put right next to it the 3a, all right? Then plus, we've got the next term, which is a b, right? So we're looking through here to see if there's any other b's. There's one right there. So we're going to put that next to it right there, so plus 11b. And then we have a 9, and we have a 21. And those are both constants. Those both have the same terms as well. All right, so now we have rewritten the expression with all the like terms being placed close to each other. All right, and then the final step is to just add the coefficients that have the same variable. So this 4a and this 3a, they have the same variable, a, so we can add them together to be 7a, all right? And 5b plus 11b, that's 16b, all right? And 9 plus 21, that's 30. And once we get it to this right here, we can't go any further, all right? Now I'm going to address a common mistake that I see with a lot of my students, all right, when they're first starting out, and even sometimes when they've been working on this for a while, all right? When we get it to this point right here, our brain tells us, I want to get it down to just one number, all right? And so, you know, I see a lot of students will do this. Well, they'll just take this, they're like, okay, well, I'm going to simplify it because the question said simplify the expression, all right? So I'm going to take that and I'm going to just add them all together. That's what students think, okay? I'm going to do 30 plus 16, that's 46, plus 7, that's 53, and I'll see this answer quite a bit, all right? Once you get to this point, some students will keep on going, and this is wrong, okay? You don't want to do that. When you get it to this point right here where there's only one term that has a letter A. There's only one term that has a letter B or a different, variable. Or there's only one constant. Once you get to this point, you need to stop. Okay? Stop. Because you cannot combine those together. You can't combine those A's with those B's because we don't know what A is and we don't know what B is. Those are just letters that represent an unknown number. When we found out what that number would be, we'd have to multiply it by that 7 because that's what that's telling us to do right there. So because those are A's and those are B's, we cannot combine those together. I mean, A could be 2 million and B could be -2 or -5. We have no idea what those, it could be an infinite number of numbers, and so we can't combine those together. Don't try to write that any more simple because it'll be wrong. That's as simple as you can get that right there, all right? Good deal. All right, let's try one more, and then hopefully you can, you'll finish out the lesson, all right, that you'll understand. Okay, so that we've got this one right here, this expression right up here. I want you to think about this expression, okay? And I want you to answer these questions right here. But before you get to the question, there's a little hint, all right? You're going to take this. There's something that you need to do to this before you ever start working with it, all right? So try to think about what that is and try to apply that. And then go on to answering the rest of these questions. Maybe you want to hit pause so that you have time to be able to do all that, and you can come back and get the answers. All right. The first thing that you want to do to this is you want to turn that to an addition problem. By going to that subtraction right there and applying keep, we're going to keep the 3x the same. We're going to turn that subtraction to an addition, all right? And then we're not going to stop there. The next number, that 5x, we have to turn it to its opposite, to the -5x, okay? And then we can accurately identify the terms. There's -9 and 3x and -5x and 6. And then we can go about rewriting the expression with the same terms next to each other. You have 3x plus a -5x, and then you have that -9 plus that 6, and it's all being added together, all right? And so now we can go on to the last step of combining like terms. You have a 3x plus a -5x. That combines together to a -2x, and then that -9 and a +6, those combine together to be a -3 because they have different signs. You subtract to keep the sign of the larger number, all right? So you've got -2x plus -3, all right? That is as simple as that can go. Maybe there's one step simpler that we can go, but that we can't combine this negative 2x with that negative 3 because that has a variable and that one doesn't. And that x right there could be any number of numbers, an infinite number of numbers. So we can't do anything more to combine these. But there is one last step if we want to write this as nice and cleanly as we possibly can. And that is to address this situation right here. We have a plus negative. So we're going to apply a reverse keep change opposite, all right, which is going to be keep the number in front, negative 2x, change that addition to subtraction, and change that negative number back to its opposite, to a positive 3. All right? So this is right, this is better, just like that. Okay? All right, in this video, we learned how to combine like terms. Write comments down below if you have any questions about this. Again, if you haven't subscribed already, you might want to hit that subscribe button down below. If this was helpful to you, hit the like button, all right? And share it with your friends. Again, we'll be doing this the rest of the year. And this is the channel where I try to make you a middle school master. So I hope you have a great day. We'll talk to you next time.